Hey physicists, in this video I want to show you two examples that are really basic examples of dynamics, the beginning of forces and how they affect the motion of an object. So we just finished all of the kinematic stuff. What we're going to do is attach to the end of that forces, and if you remember Newton's second law says that force equals mass times acceleration, or the acceleration of an object is directly proportional to the force that's put on it, and it's inversely proportional to the mass. So what ties this to the previous section that we studied is that acceleration value. So if you think through what we've studied so far, we have an x, we have a vi, we have a vf, and we have a t, and we're going to use all of those to find our acceleration now. And once we have the acceleration, we can use that to find a force acting on an object. Or we can go the other way. We can use the net force that's acting on an object to find the acceleration, to find one of those kinematic variables. So let's talk through this first problem here. A force of 32 newtons is exerted on a 95 Newton block that is at rest on a flat plane. Neglecting friction, we want to draw a free body diagram. So the first thing I'm going to do is I'm going to put my box on a flat plane. I'm going to put my dot, that would be sort of where the center of mass is of the block. I know that the force of 32 newtons is pushing it forward, so I'm going to draw an arrow pushing it forward and label that as F equals 32 newtons. I also have that it's a 95 Newton block. Now, since that's telling me 95 newtons, that's giving me the weight of the block. So the weight is going to be pulling down towards the center of the Earth. And I'm going to say that that force, which is the force of gravity, is going to be 95 newtons. You will also see a lot of physicists where they will not like to use these subscripts, and so they will use a W for weight, try and make that be one letter. Then we can also look and say, hey, this box isn't moving up or down at all, which means that that can't be the only force acting on the block in the up and down direction. There has to be another force acting on that block that is going up, that is equal and opposite to that 95 newtons. So there will be a 95 newtons going up. And what we're going to call that is the force normal, either Fn, or again, if you want to simplify it down to one letter, you can just use a capital N. Just don't confuse it with the newtons, that is the unit there. So we know that these two cancel out because the block isn't moving up and down at all, so there is no acceleration in the up and down direction. Now, if we did have friction, then remember that friction would act against our motion, and friction would be going this way, and we would label that as FF. Or sometimes you'll just see that as a cursive F. That would be if you're doing the single unit. Now, from there, the next step is we want to know what the mass of the block is. Now, remember that mass is a special form of the weight. You get it from the weight. So to find the mass, you take the weight, divide by 9.8. Or another way to think of it is we can use Newton's second law, F equals ma, and say that if this is the force of gravity, this has to be the acceleration of gravity. So if I take the force of gravity, which is 95, equals m, and I divide that by 9.8, then that is going to give me what the mass of the object is. So calculating that mass then, I get a mass of 9.69 kilograms. Then I'm going to say, well, what will the acceleration of the block be? And if I'm trying to find the acceleration, I know there's no acceleration up and down, so these two forces cancel out, this one and this one. I know there's no force of friction, so that cancels out. So the net force, or the sum of all the forces, has to be that force that's pushing it in the forward direction. So I have F equals ma. I'm going to have that 32 as my net force. I know the mass now is 9.69, and I can calculate an acceleration. If I divide that over, I'm going to get 3.3 meters per second squared. So that'll be the acceleration of the block. Then remember, now that we've found the acceleration, we can find any one of these kinematic values over here. So it tells me in the problem that it's at rest on the plane, so I know that the initial velocity is 0. What will the block's final velocity be? I'm looking for VF. And we just found the acceleration, 3.3, after t is 4 seconds. Find that value. So what equation do I have that has those four variables? I'm going to do VF equals VI plus AT. So I'm solving for VF. My initial velocity is 0, 3.3 times a time of 4, and that's going to give me a final velocity of 13.2 meters per second. So that's the first way that we can do it. You can be given the different forces acting on the object and use that to calculate acceleration, and then use the acceleration to calculate the kinematics. In the next one, we'll go the other way. We'll be given the kinematics and solve for the forces.